Dear friends, I would like to introduce myself. I am S.J. Pradeepa, Department of Chemistry, Hindustan College of Engineering and Technology. Today, I would like to present you the estimation of chloride in water sample. This is one of the water quality parameter test that we can do in our chemistry lab. So, what are the things I'm going to discuss with you in this slide was aim of the experiment, principle, procedure, calculation, and result. So the aim is to estimate the amount of chloride present in the given water sample being supplied with standard solution of sodium chloride of strength 0.01 N. Now I'm going to tell the principle of this experiment. Generally, water contains chloride in different forms in the form of minerals like sodium chloride, potassium chloride, calcium chloride, magnesium chloride, and even in the form of bleaching powder. But the chlorine level, that is the permissible level present in the drinking water, was 250 ppm. This was the standard given by according to a WHO. This is only to the permissible limit more than 250 ppm is not desirable for drinking purpose. So if the water is fit for drinking means the chloride level should be less than 250 ppm. So we are going to estimate the amount of chlorine given in the water sample by a method called argentometric method or Mohs method. So how I'm going to estimate the amount of chlorine in the water sample means by using silver nitrate. What is the reaction that will happen between the silver nitrate and the chlorine present in the water means a silver chloride precipitate will be formed. And an indicator which is added in this titration is potassium chromate. This potassium chromate indicator is having yellow color and it will titrate it against the silver nitrate and water sample. At the end point, when all the chloride present in the water sample has been removed and the yellow color of the chromate changes into a reddish brown due to the following reaction which is given in the slide. So now I'm going to tell about the procedure of this experiment. There are two titrations are there. Titration 1 is standardization of silver nitrate. Titration 2 is estimation of chloride in the water sample. Titration 1, standardization of silver nitrate means we are going to find out the strength of the silver nitrate in this titration. For this, burette solution is silver nitrate, pipette solution is 20 ml of standard sodium chloride. Indicator is potassium chromate, which is an yellow color indicator. First, we have to wash the burette and fill the burette with the silver nitrate, and then wash the conical flask. Take the pipette, pour out 20 ml of sodium chloride into the clean conical flask. And then we have to add a 2 drops of indicator, potassium chromate, into the conical flask. Actually, after adding, you can see the color will be an yellow color. After adding the potassium chromate to the conical flask, the color will be yellow color. After this, we have to titrate it against the silver nitrate. The color changes from yellow to reddish brown is the end point. When the end point is arising, automatically we have to off the burette and note of the reading from the burette. So the color will be changes to reddish brown. This is the color change we will get over here. And after getting this reddish brown, we have to stop the titration, note down the value in the burette and try for concordancy. This is the first titration. Second titration is estimation of chloride ion. Here we have to take the burette solution as same silver nitrate. Pipette solution is 20 ml of water sample which we have to find out the chloride. Then you have to add 2 drops of indicator to the water sample, 20 ml of water sample, and again the color changes to yellow color. Then we have to titrate it against the burette, that is silver nitrate. The end point will be color changes from yellow to reddish brown. So you can see now I'm going to show the two variants, that is you can see here before titration the conical flask it will be an yellow color. After titrating against silver nitrate the color changes from yellow to reddish brown. Okay, so this is the end point, this is the end point we will get for this titration. After doing this, we have to do the calculation for the experiment. Titration 1 is standardization of silver nitrate. From this, we are going to find out the strength of the silver nitrate. So volume of sodium chloride that we have taken for doing this titration is 20 ml. In final reading, whatever the reading that we are getting from the burette, that we have to write here. Try for concordancy, write the concordant value here. So calculation, volume of sodium chloride is 20 cc, strength of sodium chloride is 0.019, which is given to you. Volume of silver nitrate is the burette reading that you have got for the titration, and strength of the silver nitrate according to the V1N1 you have to find out the N2, strength of the silver nitrate. That we strength of the silver nitrate value, what we have observed from the first tabular column, that only we have to enter here. That is strength of silver nitrate. We have got the answer now for the before calculation. That strength we have to substitute it here. So in the second tabular column, the volume of water sample taken is 20, and the burette reading, whatever the reading that you are getting from the burette, that you have to write here for the water sample. So volume of the silver nitrate, you have to write the second titration concordant value here. Strength of silver nitrate 0.01, volume of given water sample that you have taken is 20. So according to V1N1 calculation, you will be finding out the strength of given water sample. Now we have to find out the amount of chloride ion present in the 1 liter of water sample, that is our aim. So what we have to do means, the formula is strength of given water sample into equivalent weight of chloride into 1000. So the strength into equivalent weight of chloride is 35.45 into 1000. We will get the amount of chloride present in the given water sample. That we have to write in the result. Amount of chloride present in the whole of the given water sample is equal to whatever the answer that we are getting. You have to write unit is ppm, that is parts per million. So by this method, argentometric method, we can find out the chloride present in the drinking water. This is one of the water quality parameter tests that we can do in our chemistry lab. This is a volumetric titration, using a volumetric titration. Thank you.